example, which is going to connect a lot of the ideas we've learned in the previous videos. So we've been given the weight of a sample is 200 newtons, the volume of that sample is 0.013 meters cubed, its specific gravity of the solid is 2.65, and the moisture content is 20%. And it's asked us to find E, the void ratio, and gamma dry, the dry unit weight. Okay, so the first thing we need to do is look at what's given us. So the weight of this sample. So we have to assume that that weight is the entire weight. So in other words, the weight of the water and the weight of the solid. Okay, it hasn't said that it's oven dried or anything like that, and it hasn't given us any indication that it's actually just the weight of the solid. So we have to assume it's the full weight. And the volume of the sample, once again, we can't assume it's just the volume of any particular component. It said the volume of the sample. So we have to assume that's the volume of the air, the volume of the water, and the volume of the solid. So let's just get some idea of where we want to go with this question. We want to be able to find E, okay, the void ratio. And once we find the void ratio, it's going to be very easy to find gamma dry. So let's just have a look at what the void ratio is again. The void ratio is given by the volume of voids over the volume of solid. Okay, so what we're going to have to do is we're going to have to get somehow information based on volumes. Okay, we've been given a volume of just the sample and the weight of the sample, so we have to be able to get back to just volumes of our components, and then we might be able to find the void ratio. Okay, and we also know that the void ratio is equal to the total volume minus the volume of the solids over the volume of the solids. Okay, so in other words, if we can find just the volume of our solid, we've been given the total volume, we want to be able to find the volume just of the solid. Okay, that's going to help us a lot. So the way we're going to go about that is that we know the moisture content equals the weight of the water over the weight of the solid. Okay, and we also know that the total weight is the weight of the water plus the weight of the solid, because we don't have weight of air, which equals 0.2 kilonewtons. Okay, we can substitute in for the moisture content, would be 0.2, it's the same as 20%, equals weight of water on weight on solids. Okay, so we have two simultaneous equations here which we can solve to get the weight of the solid and the weight of the water. Okay, and then once we get the weight of the solid, I'm then going to show you where we're getting the volume of the solid, and then we can find the void ratio. So the weight of the water will equal 0.2 the weight of the solids. If we substitute that into this equation here, we would get that 0.2 weight of solids plus weight of solids equals 0.2 kilonewtons, which means that 1.2 weight of solids equals 0.2 kilonewtons, which means that the weight of solids would equal 0.2 divided 1.2, or 0.166 kilonewtons. We can then go and sub that into this formula here, which means we get the weight of water equals 0.2 the weight of solids, which is 0.166, which equals times 0.2, so 0.033 kilonewtons. Okay, so just to give a quick summary, the weight of the water is 0.033 kilonewtons, and the weight of the solids is 0.166 kilonewtons. Alright, the important thing we need is the volume of the solids, okay? Then we're going to be able to find the void ratio. So, we remember now that the weight of a solid was equal to its volume times the specific gravity times the bulk weight of water. Okay, we did this in the first video, which means we can now rearrange to get the volume. Okay, the weight of the solid is 0.166 kilonewtons on top of the specific gravity, 2.65, multiply gamma W is 9.81 kilonewtons per meter cubed. So you can see that all the units I'm using here are kilonewtons and meter cubed. If we work this out, 0.166 divided by 2.65 by 9.81, we get the volume of solids equals 0.0064 meters cubed. Okay, let's get another sheet of paper. So 0.064 meters cubed, right? So we know now that the total volume, which we had in our question, so the total volume is 0.013 meters cubed. Okay. And the volume of the solid we just found is 0.0064 4 meters cubed, which now allows us to find our void ratio, because the void ratio is the volume of voids on the volume of solid, and we know that we can rewrite the volume of void as the total volume minus the volume of the solids on top of the volume of the solids, which will equal the total volume 0.013 minus 0.0064, and this is all divided by the volume of the solids, which is 0.0064, which we can then find 0.13 minus 0.0064 divided by 0.0064, we get 1.03 roughly as our void ratio. Okay, so we've found our void ratio. Now it's easy to find gamma dry. Gamma dry is equal to G outside of 1 plus E, G on top of 1 plus E outside of gamma W. So we know G is 2.65. We just found E is 1.03, right? And we know gamma W is 9.81 kilonewtons per meter. So we can work this out, and we get 12.81 kilonewtons per meter cubed as our gamma dry. Alright guys, hope that helps. Just a quick note, this was quite a complicated question. It involved almost everything we've done so far. Just a heads up, it's just in this unit you're going to be dealing with complicated equations like this and trying to figure out all this stuff. When you come to some of the future units, some of the other subjects coming up, you're not going to have to worry about, say like in a 6-mark question, you're not going to have to worry about doing all this. This would be a very small component. It would be a very easy transition. It might give you everything, and you might just have to find gamma dry, for example. You wouldn't have to go through this process. So as I said in some of the other videos, don't get too bogged up and worried about all this process. It's only going to be a very small component of the course. Most of the rearranging of equations and all that type of stuff, finding things, are just for this actual unit, just for this section of the course. In later sections, it's going to be a lot easier. Hope that helps.